Welcome to a presentation brought to you by the American Wood Council. Thank you for your participation in our webinar today. This webinar is intended to provide general information only and does not constitute professional or engineering advice. Please note that this webinar is being recorded, and by remaining a participant, you automatically consent to such recordings. If you do not consent to being recorded, please disconnect from the session. This presentation is worth 1 LU/HSW with the AIA and 0.1 credits with the ICC. To receive credit for the course, you must attend this webinar for a minimum of 50 minutes. At the end of 50 minutes, you will see your certificate appear on your webinar console. Your certificate will also be uploaded into your learner profile on learn.awc.org, provided you registered for today's webinar with the same email address as your account profile. At the end of today's session, our presenter will have a live Q&A with the audience. Please input your questions into the Q&A panel throughout the session. And now, for today's presentation.
My name is Ed Lisinski. I'm the Midwest Regional Director for the American Wood Council. And today we're going to talk about the 2024 IRC significant changes to the deck code provisions. We'll actually go through a lot of the existing language as well. So if you're not familiar with the deck code provisions that are in the 2024 or any edition of the IRC, we'll probably cover a lot of that as well. Not just the 2024 changes, but we are going to focus in on those changes. As mentioned, this class will give you ICC and AIA credit, and more information on that can be provided afterwards. And here's the course description. I'm not going to read through this, but basically we're going to talk about decks and again, in particular, the changes to the 2024 IRC. Same thing here. I'm not going to read through the learning objectives, but hopefully you saw these when you signed up for the course today. And then to get us started, again, we're going to focus in on the 2024 IRC, but many of these provisions are existing, so they may also appear in earlier editions of the code. When using any code, make sure you check the reference standards section to make sure you're using the appropriate edition of the standards that go with that code. For the 2024 IRC, that will reference the 2024 National Design Specification for Wood Construction, or the NDS, which is one of several AWC standards referenced in the code. But the NDS is the most relevant to this section of the code. Also on the screen is a copy of the latest DCA 6, which is the AWC Prescriptive Deck Code Design Guide. So let's just get into some basic code requirements before we get into the actual deck code requirements. These next sections apply to all construction, but I'll probably make some comments on how they fit in with decks in particular. So this is a basic code section that's very important for decks. I'll note that while the text in this part did not change, the section number changed in the 2024 IRC. It went from R102.7 to R102.6. But this section basically says that existing structures can remain under the code in which they were constructed until something happens to it, right? And what could happen to that existing structure? Well, you could do an alteration, addition, or repair. Then the new portion, whatever is involved in your addition, alteration, or repair, would have to comply with the current code, while the rest of the building can remain under the old code under which it was originally approved. The addition, alteration, or repair cannot make that existing building less compliant with the code. If it does, then that portion of the building may have to be brought up to the current code. The last sentence here was new for the 2024 code, but it's really not relevant to decks. So let's take a look at how that section may be related to a deck. Here's an existing house that was built under maybe the 2015 or 2018 IRC. That house can remain exactly how it was built. If the owner now wants to add a deck where those patio doors are on the first floor, I'm assuming that's a first floor with a walkout basement, the deck complies with the 2024 IRC and the house stays under the code under which it was built. However, if those doors from the walkout basement are a required exit and the deck above needs a post or a stair that comes down and blocks them, well, then the existing house is now less compliant with the code because that required exit door is blocked. They could possibly move the post or the stairs to another location so that it doesn't interfere with the door, but maybe there's another reason that it needs to actually be there. Then the existing building would have to be made compliant by possibly relocating those doors or by finding another egress path from the lower level, the walkout basement. If the stairs are moved to the other side but run along the building to the right, going to the right on the screen, they could run right into that last window, which would then trigger that window to have safety glazing because it's now along a stair or walking surface. So you can see how a deck may require alterations to make sure that the existing house is not less compliant with the code under which it was built. All right, moving on. No new information here, but just make sure that you're getting manufacturer's installation instructions with products that are required by the code to make sure that they're being used and installed correctly. This is especially true with newer fasteners or foundation systems that you might find on the deck or products that you haven't seen before. Decks that are exempt from permits have had their place in R105.2 for many code cycles. The 2024 IRC just clarified that those decks can be on a dwelling or a townhouse, so you can see the new underlined language there. The code also moved the location of the required exit door from the house, so the section pointer here was updated. R104.9.1 is for materials and equipment reuse. This section had some updates in the 2024 IRC. The issue of reusing existing materials comes up often in decks when someone's replacing a deck and maybe wants to reuse some of the structure or some of the deck boards. Those reused materials need to be in good condition and again approved by the building official, as you can see. Anytime you see the word approved in the code, that is approved by the building official. There are major changes to the section on alternative materials, design, and methods of construction in the 2024 IRC. There's now much more simple charging language for this section, followed by several subsections that will provide more guidance on how to approve alternatives. Alternatives are always important in deck building because so many new products come on the market for fasteners, guards, or other products, and the codes cannot keep up with them. So this section gets used often for decks. One thing to keep in mind, section R104.7.3 lets you know that you need to maintain records of alternative materials, designs, and methods. So that has to be in writing and kept in the official records for as long as that deck is out there. And I mentioned this guide earlier, but AWC has our DCA 6 guide, which is our prescriptive residential wood deck construction guide, and that can certainly be used as an alternative. I mentioned that many of these new products on the market or get onto the market before the codes can actually recognize them. When that happens, again, rely on the manufacturer's installation instructions, but also rely on ICC ES reports. If you aren't familiar with them, here's what one would look like. Always look for the beginning look for the date at the beginning of the ES report, and that's going to tell you when it's subject to renewal. If you haven't read through these before, section 1 will list out the codes that product's been approved for use in and the properties evaluated. Section 2 will explain the uses. Section 3 is a description of the product. Section 4 covers the installation of the product. And then section 5 explains the conditions of the use. Okay, so that's some of the basic information found in chapter 1. Now we're going to move on to the loads that are affecting the decks. All the load sections were slightly updated in the 2024 IRC to comply with ASCE 7-22. There were significant changes to the wind, seismic, and snow loads. Again, they don't really affect decks all that much, but I just wanted to make sure that you were aware of those. The table R301.5 talks about all the different uniformly distributed live loads that are in the code. There's no changes to this section. However, you'll notice that balconies and decks have a section in here, guards, guard infill components, and handrails. So if you do end up with an engineered deck where they don't follow the prescriptive path, this is where they'll be pulling those loads, either from here or from ASCE 7-22. Table R301.7 is the deflection for structural members, and you'll see in the 2024 code they excluded guards and handrails from the all other structural members section there. So those don't guards and handrails no longer have a deflection limit in the code. Here's a graphic of how the gravity loads work on a deck. All loads, no matter how or where they act on a building, need to be resolved into the ground through the foundation. You can see how half of the load from that deck, that's on the deck surface itself, is going into the ledger board, which is hung on the side of the wall through the ledger bolt connections, and the other half is going out to the beam. That ledger board, though, and that ledger bolt connections is probably one of the most critical connections on the deck because it doesn't have anything directly underneath it, nothing directly to bear on. It's only being held on by those bolts. We'll talk about that connection later on. And the same thing with lateral loads. On a deck, you may not get into a lot of loading from seismic or wind, but when you do, those loads have to make their way into the ground through the foundation. While it's not in the code itself, side sway from people moving on the deck is also a concern that would act in the same manner. All right, so now we can get into the deck requirements themselves that are found in section R507. I'm sure you've all seen decks before, but here's just a really nice basic picture of a deck. You'll notice that there's no point loads on there, no hot tubs or anything like that. It's a simply supported deck, and these are the types of decks that are covered in R507. The 2018 IRC reorganized this whole section to make the layout a little bit more logical as you go through here. So R507.1 is all the general provisions of this section. Something to always remember, R507.1, this whole deck section, only applies to exterior wood frame decks on residential properties. If you want to frame it out of steel studs or other materials, you'll have to go through engineered design in accordance with R301. Same thing if you have higher point loads or exceed the spans that are in the span limitations in the code. And then here is engineered design through R301.1.3. And again, that's an option then for designing a deck that doesn't fit into R507. Section R507.2 is all about the materials. If you have any questions about materials in R507, this is where you would go to find those answers. This section covers wood, plastic composites, fasteners, splashing, and then alternate materials. R507.2.1 previously required all wood material to comply with the requirements for decay and termite protection, and the requirement for sawn lumber to be number 2 or greater. The 2024 IRC narrows that down to only require it for structural members, so no longer required for all wood on that deck. It also updates the reference to the decay and termite sections. Those changed to R304 and 305. And we'll take a look at that real quick. So section R304.1 is for the decay protection of wood members used anywhere in the code. It did move from section R317. So if you're used to seeing it in 317, it's all been moved into 304 now. The only real change that affects decks to that section is that in item number 8, portions of wood structural members that form the structural supports, previously it said of buildings, balconies, porches, or similar permanent building appurtenances. Just to be clear, they added the word decks into that list of building materials or building structures. And then towards the back there, the bottom of the section, the words would prevent moisture or water accumulation were changed to prevents moisture or water accumulation. So if there is a roof, eave, or overhang where your wood members are up inside there, and that roof eave or overhang is going to prevent moisture or water accumulation on the surface of the structural member. It would not need to be preservative treated or naturally durable wood then. There is an exception for geographical regions where you don't have decay, but that section was just added to say, instead of saying buildings located in geographical regions, it now says structures located in geographical regions, because you could have a deck just built out in the middle of nowhere in a geographical region where you don't have decay issues, and that would not qualify then if it just said buildings. So now it was changed to structures. For protection against termites, again, this used to be in R318. It now got moved into R305. The only change to this section is that, again, that pointer in item number 3 for preservative treated wood was changed to R304.1. There were no changes here for preservative treated wood, but I just wanted to give you a quick reminder on this. The preservative treated wood has to be in compliance with AWPA U1, and that field cuts, notches, and drilled holes shall be treated in accordance with AWPA M4. Again, no changes here for ground contact, but any wood that's in contact with the ground or embedded in in concrete that's in direct contact with the ground, or embedded in concrete that's exposed to the weather, has to be approved for ground contact. R304.2 is for the quality mark. Again, no changes here. Just some good reminders that, again, as you're looking at preservative treated wood, make sure that it's got that quality mark on there. It's got that label somehow on that wood. And what's all on there? You'll have the identification of the treatment plant, the type of preservative that's used, the retention level of that preservative that's used, and then the end product. And that's where you're going to see if it's approved for above ground use or ground contact use. It's also going to have the standard in which it was treated, the identity of the approved agency, inspection agency, and then if it's required to be dry. When you are dealing with decay protection, you've got two options, right? You have preservative treated wood, and then you also have an option for naturally durable wood. If you use naturally durable wood, it's a lot of people just think, well, if I use redwood or cedar, that's going to be fine. If you read the actual definition of it, though, you need to be using the heartwood of those species, except that you can get an occasional corner of sapwood, but 90% of each side of that wood has to be the heartwood of the tree. That's going to be the center section. It's going to be a deeper, darker, redder color. The sapwood is the more yellowish color. So make sure that if somebody is going to use naturally durable wood, that they are using the heartwood of the tree. And then again, 90% of each side has to be heartwood. It's going to be a lot more expensive. It's going to be a lot harder to find in certain regions of the country. So if somebody wants to use naturally durable wood, make sure that you're getting some documentation from them and really looking into that. And then again, keep in mind that it's not just redwoods and cedars. You've got redwood, cedar, black locust, and black walnut. Those are all decay resistant. And then, of course, there's also some different species then that are termite resistant as well. Engineered wood products can certainly be used on decks, glulam, CLT, structural composite lumber, engineered wood rim boards. But again, they could potentially fall under the requirements to be preservative treated. And some of these products are more difficult to find as preservative treated. But again, as mentioned, if you have a roof or an overhang or an eave that's going to protect that engineered wood, there is certainly some options to use that without protection. No changes here as well, but just keeping in mind that the fasteners for preservative treated wood are the requirements for those can be found in R507.2.3. A little bit of change to this here. So in that section, they pulled this language from a footnote that was in one of the tables and brought it out into the actual code section so that you can find this this first point a little bit easier because they found that it was getting missed. But holes for through bolts shall be drilled 1 32nd inch to 1/16 inch larger than the bolt diameter. So again, that was in the code, but a lot of people were missing it. So now it's pulled out into actual section text, so it's hopefully not going to be missed. And then also a new section was added in there, a new sentence was added in there that connectors shall be installed in accordance with the manufacturer's approved instructions. And that's just good logic. Again, I was surprised that it wasn't actually in there stated anywhere. All right, so 507.1 was the general requirements, 507.2 is the materials. Now in our 507.3, we're going to start to talk about the footings. We're going to start to build our deck up out of the ground. So no changes to this section. Deck shall be supported on concrete footings or other approved structural systems designed to accommodate the loads, right? There is a requirement to not require those footings, and that there's two options in there. The first one is if the joists are directly supported on grade, so they're just laying on the ground for the entire length. Again, they would need to be ground contact preservative treated. And then the other option there for not requiring concrete footings is that you can have some precast concrete pier blocks at grade, as long as you don't have any beams or posts on them. That deck is not 200 square feet, and then it's not more than 20 inches above the walking surface. So those are your requirements for not requiring a concrete footing or other type of footing. Again, no changes here, but the deck footings shall be placed not less than 12 inches below undisturbed ground as a minimum depth. Of course, if you're up here in Wisconsin like I am, you have to get down below the frost level as well. So you're going to need to provide that frost protection. So extending the footing down below the frost line, erecting on solid rock, or providing other means of frost protection for your deck. Table R507.3.1 is the minimum footing size for decks. This table has been in the code for a while. If you're not familiar, if you're on an older version of the code and you're not familiar with the changes that were done in the 2021 IRC, this was significantly changed in the 2021 in that, along with all these other tables, previously they just focused in on 20 pounds live load or ground snow load. All the tables throughout R507 in the 2021 IRC were expanded out to include 50, 60, and 70 pounds ground snow load. So if you are in a higher snow region, you now have some span tables in the code for ground snow that gets higher than 40 pounds per square foot. Also, another big significant change in the 2021 code was that the tributary area was changed, or another row was added in there for 5 square feet of tributary area. That's going to cover about like a 4 foot by 5 foot deck. The reason for that, all these tables, you can interpolate between two numbers, but you can't extrapolate beyond the numbers. So previously, the tributary area for 20 square feet was the smallest footing that you could use prescriptively, which caused a lot of people, they figured, a lot of builders, contractors felt that those footings were oversized, which they certainly were. If you had a very small, like again, a 4 by 5 deck, those were very large footings for that small of a deck. But you couldn't extrapolate beyond that 20 square foot tributary area. So the 5 was added in there. The 5 square foot tributary area was added in there so that you now have some smaller footing options for those smaller decks. The only change in here that was made to the 2024 code was that plain concrete was added for the thickness of the footings, just to make sure that you don't require any rebar in that concrete. And how do you find the tributary area? Well, again, I mentioned this real briefly in the when I talk about loads, but half of your load from anywhere on that deck is going to go evenly between the two different directions. So if you want to find the tributary area for that corner post that's in the upper left-hand corner, this is a 20-foot by 12-foot deck. You can see that there's an intermediate deck beam and footing and post in the center there. So you've got 10 foot on each side as you go left to right, and then 12 feet as you go top to bottom on your screen. So that corner post in the upper left, it's going to take 5 feet of load between that and the interior post going to the right of it. Coming down, it's going to take 6 feet of load before it gets down to that other post. So you're going to have a 5 foot by 6 foot area, so 30 square feet is coming onto that corner post. When you have that interior post on the bottom and the center, you now have 5 feet from the left, 5 feet from the right, and then 6 feet coming up. So you've got an area there that's 10 feet wide by 6 feet high. So 60 square feet is going to come onto that interior post down there. So again, just figure the direction halfway to the next beam or post in each direction, multiply those together, and that's how you come up with your tributary area. So 2 words were added. Now we're into 507.4, which is the deck posts themselves. We just talked about the footings, but a couple words were added into our 507.4.1 just to talk about when you're talking about the lateral restraint on the deck post footings, that it needs to be an approved connector, or else you need to embed that post 12 inches into surrounding soils or concrete piers. So not just plain concrete, but into a concrete pier. And again, that's going to stabilize the base of that post. Either an approved connector, and again, approved whenever you see that in the code is approved by the building official, or else into soil or a concrete pier. You need that 12 inches of embedment. The deck post height table, again, if you're working on the 2018 or earlier, this may seem like a lot of overkill to you. Previously, this whole section was 4 lines, 4 rows, and 2 columns. It just gave you a 4x4, 4x6, 6x6, or 8x8 post size, and then it gave you the maximum height for that deck post. What it did now in the 2021 code, broke this out into, again, 40-pound live load, 50, 60, 70-pound ground snow load, broke it out into the different species, as you can see on the table here. You have all your different post sizes, and then you've got how much tributary area is actually coming onto that post, and that's going to give you a much more accurate overall post size that you're required in the code. So this went from a very small table into 4 much larger tables, but again, it's a much more accurate representation of your required post height. One thing I'll mention, you'll see across the top on the third row down, it says maximum deck post height, and you can see that footnote A in there. Footnote A says that the post height is measured from the underside of the beam to the top of the footing or pier. So keep that in mind. If the top of your post is notched so that the beam can bear directly on it, and maybe some of that post extends up so that you can get a bolt in there. Again, it goes from the bottom of the beam, so the actual length of the post is not the post height. And then same thing down at the bottom. If you have a bottom cap connection down there, and maybe there's a 1-inch offset so that you're keeping that wood post up off the concrete with that 1-inch offset for some decay purposes. Again, it goes from the top of the footing or pier. So keep that in mind, that your deck post height is not necessarily your deck post length, right? The length of the post is one thing, but the post height that you're looking at here in the table is going to run from the underside of the beam to the top of the footing, no matter what the actual length of that post is. Footnotes are always important in the code. All right, so that's your deck post. Moving on to the deck beams. The maximum spans for wood deck beams are in that figure and in the tables R5075 parent 1 through R507.5 parent 4. And a new part was added here that says, and it's based on the joist span length and cantilever length shown in R507.6 that we'll talk about in a minute. So you do have to look at both tables here in order to determine your beam span. All right, so if you've been on the 2018 or earlier beam span tables, this is going to look quite a bit different for you. Also, it's going to look quite a bit different if you're on the 2021 code right now. So again, this is the changes for the 2024 code. What had happened previously, the 2018 or earlier, when you went in here for the beam span length, it assumed that you had a fully loaded joist on top of it with a fully loaded cantilever at the end of that joist. So the beam spans that were in there were actually fairly conservative, because again, it was assuming that you were going to put the worst case scenario of loading up on top of that. What they realized is, again, that these were somewhat conservative, and the deck builders kind of got together and said, hey, we're overspanning these beams a little bit. We need to come up with a method to kind of scale this back and get a little bit more realistic. So what they did in the 2021 code was they came up with a factor that you could apply on there, and they called it the effective joist span length. So if you're on the 2021 code right now, you've hopefully run into this. So you had the effective joist span length, which took the joist span length that you had and then applied a factor based on how much of the cantilever was out there. So if you had a really short cantilever, you could actually reduce the joist span that you're going into the tables with. If you had that full cantilever, well, then you were coming up with the same numbers that you would have previously. So it was a little bit confusing. There was a footnote and then another table that would apply that adjustment factor. And honestly, yeah, some people were getting a little bit confused by it, but it did what it needed to do, right? It did give you a much more accurate beam span. What they did here for the 2024 code, though, is just came up with kind of expanded out the joist span table up at the top, and then gave you different individual columns that you could then get to your beam span. So if we'll take the 10-foot joist span, the third one down at the top. If you go to the right there, you'll see the third row is where you first get into the 10-foot joist span. So if you have a 10-foot joist span with no cantilever, you would use that column coming down. The next one to the right, if you have a 10-foot joist span with a 1-foot cantilever, you would use that row, or that column, I should say. And then if you have a 10-foot joist span with a 2.5-foot cantilever, you would then use that column. So as you increase your cantilever, you're going to decrease your beam span as you move through that table. But what you'll also notice then, if you go to the, we'll say the fourth column over, if you have an 8-foot joist span with a 2-foot cantilever, that's going to give you the same beam spans as a 10-foot joist span with a 1-foot cantilever and a 12-foot joist span with no cantilever. So you can see how all those three options all give you those same beam sizes and beam species, based on the beam species, I should say. So again, it's a little bit easier to get in here. You can, again, interpolate between numbers in there. So that's going to get a little bit more complicated if you have to interpolate between the 12-foot and the 14-foot, and then also like a 1-foot and a 1.5-foot cantilever. But you can always go to the most restrictive and use that. When you do talk about beam spans, make sure that you realize the IRC goes from the center of the beam span, the center of the post itself. So you'll notice here in the graphics that the beam span goes from the center of the post to the center of the post each time. The figure was updated just briefly, just to say this is typical deck beam spans added in the word beam into that. So let's go through the beam section. There's some changes in here, but nothing in this first sentence here. So actually, this is the second sentence. We already talked about this a little bit earlier on an earlier slide. We talked about the beginning part of this. It says that the deck beams is based off of that table or the joist span table that we're going to see in a minute here. So moving on though, if you have different beam plies, no changes here, but those plies need to be fastened together with 2 rows of 10 penny nails, 16 inches on center on each edge. And then deck beams of other materials shall be permitted where designed in accordance with engineered practices. So again, no real change here, just added in that we're talking about deck beams. Now some information from R507.5 was slid down here into R507.5.1. So this looks like it changed quite a bit, but actually a lot of this language was actually in other sections of the code and just brought out here or slightly reworded. So R507.5.1 talks about beams and individual plies of built-up beams shall be continuous between bearing locations and continuous across bearing locations supporting beam and continuous across bearing locations supporting the beam cantilevers. So if you're just going over a post, that's where you have to have the individual plies or the beam itself bearing if you do need to splice some of those together. However, if you have that cantilever, then they don't want you to break it at that post just before the cantilever. It has to be continuous across that support when you have that cantilever on the end. So again, that was actually in the section before. They just slid it back down. The second sentence was also actually up above, and they slid this down as well. And that says a beam shall be permitted to cantilever beyond the bearing locations up to 1/4 of the actual beam span. So if you have a beam span that in those tables, you're permitted to have an 8-foot beam span, you can now do a 2-foot cantilever. That's 1/4 of the actual beam span. And then again, the bottom sentence there just adds in the word length just to make sure that it's very clear that the ends of the beams shall have 1.5 inch bearing length onto the wood or metal and not less than 3 inches of bearing length onto concrete or masonry. So the beam connection to the supports, the deck beams, the new sentence here says that deck beams shall be connected to supporting members to prevent lateral displacement. Previously, this sentence in the earlier versions of the code said that deck beams shall be attached to supports in a manner capable of transferring vertical loads and resisting horizontal displacement. So they simplified this sentence quite a bit, and again, just kind of clarified that it is that connection to the supporting members to prevent that lateral displacement. And then the figures were updated, just the numbers in there, so no changes to that. But they did have to get renumbered. All right, so that's it for beams. R507.6 is the deck joists. Again, no changes here. The maximum joist spacing shall be limited by the decking materials that are on there. So it's going to go with the decking materials that you'll find in R507.7. Also could affect your joist span length, but otherwise the joist spans are going to be found in tables, table 507.6. And here's what that table looks like. Again, if you're coming from the 2018 or earlier, you're going to now notice that this table gets expanded out to the 50, 60, 70 pound live load or ground snow load. But you'll go into this table with your joist spacing, figure out your joist species, the joist size, come across, find your joist span, and then also come up with your maximum cantilever that you're permitted. Just like beams, keep in mind that the joist spans go from the center of bearing to center of bearing. So that could be from the center of the post. It could also be from the center of the bottom of that joist hanger seat, that metal seat on a joist hanger. You're going to go from the center of that seat to the center of the beam. And again, you can see that in the graphics in the code. Even if you have a joist hanger on both sides, again, you're going from the center of the bearing of that joist hanger to the other center of the joist bearing on that joist hanger. So again, just like we saw with beams and just like we saw with posts, the joist length is not the same as the joist span. The joist length itself is going to be a little bit longer. So deck joist bearing, again, just added in the word length for bearing on that, just to clarify that we're talking about that 1.5 inches of bearing length onto wood or metal and 3 inches of the bearing length onto concrete or masonry. No changes here, but again, just really good information. Joist bearing on a multi-ply beam or ledger shall be fastened in accordance with that table. And then joist bearing on top shall be attached with a metal connector or a mechanical connector. Joist framing into the side of a beam or a ledger board shall be supported by approved joist hangers. And then the lateral restraint, the ends of the joist need to be provided with some sort of lateral restraint to prevent rotation. Typically, the joist hangers are going to provide that if you have that, but you can also do it with blocking between the joists. And make sure that the depth of the joist or the joist hanger or the blocking is not less than 60% of the joist depth. And then where the lateral restraint is provided by rim joist, they shall be secured with 3 10-penny nails or 3 number 10 3-inch long wood screws into the end of those joists. So you can do it with joist hangers, you can do it with blocking, or you can do it with a rim joist out there on the end. 507.7 then gets into decking. So the maximum allowable spacing for joists supporting the wood decking, excluding stair treads. This used to say excluding stairs, or stairways, I should say. They changed that to stair treads to be a little bit more accurate. We're talking about the stair tread for decking. And then that wood decking shall be supported or should be attached to the joists with 2 8-penny, it used to say threaded nails, now it says deformed shank nails, or 2 number 8 wood screws. So those are a couple little tweaks in the 2024 IRC. Also, if you're using plastic composite decking, go back to that materials section, Art 507.2, and look there. If you have other decking materials, again, install those per the manufacturer's installation instructions. And then here is that table for the maximum joist spacing based on the wood decking. So again, for joist spacing, you do have to look at the joist table that was in our 507.6, but also pay attention to the decking section here, because that could also affect the joist spacing. Vertical and lateral support is required. We're supported by attachment to an existing wall. Deck shall be positively anchored to the structure to support both vertical and lateral loads. We talked about those earlier on. And then here's just a typical deck. For decks with cantilevered floor framing members, you also have to design to resist the uplift forces and the live load forces that are acting inside the house itself. So here's a cantilevered deck. So this is the floor framing from inside the house that's extending out and forming the deck. So again, you have to worry about the live load that's on the deck, the live load that's inside the house, and then also some uplift loads from winds that are coming into that. And then where a positive connection to the primary building cannot be verified, deck shall be self-supporting. And what that looks like is right here. You can see the right along the house, they put a new line of beams and columns, or beams and posts, so that deck is completely self-supporting. I talked about earlier how the existing building can remain exactly as it is. Well, you can see in this picture, if they're going to put a deck right here, those windows that are existing on the house, they're perfectly fine to stay there as they were previously. But once you put this deck here, now they're really close to that walking surface. So those windows that they weren't previously would have to be changed over to safety glazing because of the proximity to the walking surface. All right, so vertical and lateral support at the band joist. A little bit of tweaks to some of this, so we'll take a look here. First off, the ledger details, and again, I mentioned this earlier, that ledger connection is probably the most critical on a deck. So a little bit of tweaks to this just to make sure everybody is on the same page. First off, when you are doing a ledger board, it has to be a number 2 grade or better. So that got added into the code. It was in a different section earlier, actually, I believe, and it got moved here just to make sure it didn't get missed. And then if you do preservative treated deck ledgers, that's one thing. But if you use naturally durable wood, then they do have to be decay resistant naturally durable wood, just using the defined terms there. And then deck ledgers shall not be supported on stone or masonry veneer. A very important point when you're talking about ledger details. And here's that connection. So if you do have a stone veneer or a masonry veneer, you have to figure out some way to alternatively support that ledger. So you can go into solid concrete. You can remove some of that brick and put some backer boards in there. But again, you need to actually get that into a structure and not into the veneer. Ledgers, again, no changes here, but ledgers cannot support point loads. So if you do have a beam that's coming in, you need to add in an additional post or take that beam all the way into the actual structure itself. The band joist details for the house. The band joist that's going to support the ledger has to be a minimum 2-inch nominal solid sawn lumber or a 1-inch nominal engineered wood rim board. So again, you have to have some solid wood for that ledger to attach to on the band joist. A lot of times you're going to have floor trusses, and they'll often just do a ribbon strip of OSB. That's not a sufficient connection, right? You have to have, again, a 2x sawn lumber or a 1-inch engineered rim board to attach that deck to. A little bit of tweaks to the, again, just more editorial stuff here, but ledger to the band joist details. Where the ledgers are fastened in accordance with the table, fasteners shall comply with section R507.2.3 and then be installed in accordance with those tables and the figures. So this is some information that is new to the code. It actually was in the NDS previously, but a lot of people, again, weren't finding it there. So the deck industry, deck builders actually brought this into the code just to make sure that everybody saw this. But if you're drilling hole, you have to pre-drill holes for your leg screws for your ledger board to your band joist detail or connection. But those leg screws shall be pre-drilled with 2 different drill bits. So you have a 1/2-inch diameter that's drilled through the ledger and the sheathing if you have sheathing on there, and then a 5/16 to 3/8 inch diameter hole is then drilled into the band joist. Reason for that is you don't want that leg screw to bite into the or split or do anything to that ledger board. You want that to be basically smooth through there, so that the nut and the washer on that leg screw can suck in that ledger board and be tight to the structure, then to the rim band joist that's in there. So you want the teeth of that leg screw to bite into the band joist and not into the ledger board itself. So again, that information's out there. People should have been doing this, but nobody was finding that in the NDS. And here's that ledger connection to the band joist table with your fasteners. I'm going to skip through some of this stuff because we're starting to run a little bit short on time. And then again, the placement here. So no changes to these. They have some great figures in the code on the staggering and the distance to the edges for those leg screws. And then again, here's another detail on that. All right, so here's some of the definitely new stuff here for the 2021 code. Again, those ledger connections are so critical that they wanted to make sure that the flashing and the water-resistant barriers and everything around those ledger boards were very critical and were really spelled out in the code. So This is a brand new section in the code for ledger flashing. So where ledgers are attached to the wood frame construction, flashing shall be installed above the ledger to prevent the entry of water into the wall cavity behind the ledger. So that flashing needs to extend vertically not less than 2 inches above the ledger, and then come down on top of the ledger itself, and then extend out horizontally at least 4 inches beyond the ledger face, sort of an L-shaped flashing, or it can extend down the ledger face not less than 1/4 of an inch down the ledger face in a Z flashing type style. You do have some exceptions where there's a window or a door that's above there. Yeah, you can't get that 2-inch leg of the flashing up above the ledger if there's a window or a patio door there. And then the flashing is not required where the ledger is spaced horizontally from the exterior wall covering not less than 1/4 inch to allow for the drainage and ventilation behind the ledger. So that's the ledger flashing itself. There's also a requirement here for the water resistant barrier. So that water resistant barrier that's on the house shall be lapped over the vertical leg of the flashing or the counter flashing and extending up the wall not less than 2 inches or the height of the vertical flashing leg, whichever is less. So if you do have a window or a door there where that vertical flashing leg is shorter than 2 inches, again, that water resistant barrier just has to at least cover that. The water resistant barrier shall continue from the top of the ledger flashing down the wall. So when you have that ledger flashing, the water resistant barrier has to at least extend up to the top of that ledger flashing and go down the wall behind the ledger itself. And then exceptions on there, some flashing shall be permitted to be placed against the face of the water resistant barrier when you have a self-adhered membrane counter flashing is installed. And then again, flashing shall be permitted to be placed in front of the water resistant barrier and behind the existing wall covering where ledgers are spaced horizontally from the exterior wall not less than 1/4 of an inch to allow for drainage and ventilation behind the ledger. So if you do have some washers in there to hold that ledger board away, again, it gives you some requirements for that water resistant barrier. Again, the most important part here is that water resistant barrier is going to be lapping down over the top of that ledger, but then also coming up behind that entire piece of the ledger and then going down behind the ledger board itself, behind that ledger flashing. So you want to maintain that water resistant barrier, but also if you do have that self-adhered membrane, you can certainly use that as well. When they put this into the code, they realized that a lot of people had different methods for flashing and providing the water resistant barrier around ledger boards. So they wanted to maintain a little bit of flexibility for people who are doing other methods that have been working. So you can also use that self-adhered membrane. Existing walls, so if you're putting a deck onto an existing building or an existing house, pretty much the same thing here. Again, that water resistant barrier has to come down over the top leg of that ledger flashing and then also extending up behind that ledger flashing up that vertical leg. But then you don't necessarily have to do the entire wall. So if there wasn't a water resistant barrier before, you don't have to remove all of the exterior sheathing or exterior finish materials. You're just going to go 2 inches above the ledger and then at least a 1/2 inch beyond the sides of the ledger. So really just flashing and putting in that water resistant barrier in the location of that ledger board and the ledger flashing. And then exterior wall covering shall be terminated above the finished deck surface in accordance with the manufacturer's requirements. With an exception on there that exterior wall covering shall be permitted behind the ledgers when it's capable of resisting compression from that ledger attachment. So you don't necessarily have to remove your exterior wall covering as long as it's solid. It's not going to get damaged by compressing that ledger against it. But again, you can't connect that ledger to the exterior wall covering. It has to go through and get connected into that rim board of the house itself. So those are all the new sections in 507.9.1 that are covering the ledger flashing, the water resistant barrier, and the exterior wall coverings. So all that stuff was brand new. Now we're back into some existing requirements here, and we'll wrap this stuff up real quick. The lateral connections, still the same thing there. You can have two tension devices, 1,500 pounds, and you can see that here. Again, no changes to this stuff. The other option then is to do 4 clips at the bottom. Again, that lateral connection, and each of those are 750 pounds, and you can see that here. Bottom. Exterior guards, again, nothing really changed here, but it is fairly new for the 21 code. So if you're on the 2018 or earlier, some of this stuff, it used to point you out into the guard section for the rest of the dwellings. It now has its own section here for guard support. And then where required, again, those guards are required anytime that the walking surface is more than 30 inches vertically from the grade below, at a point 36 inches away from the edge. So as you can see here, if you're a 30-inch drop off, anything within 36 inches of that needs to have that guard. So even though the 30-inch drop off is right at the very edge of that deck, a portion of that deck is within 36 inches of that 30-inch drop off. So that guard would need to wrap that corner a little bit. Again, 2021 code had a whole bunch of new sections here on guards supporting into the side of the deck framing, or guards that are supported on top of the deck framing, and how to attach those. And again, if you do get into different guard systems, following the manufacturer's installation instructions on those is going to be most critical. And then again, just some other requirements for wood posts on deck guards and plastic composite guards. Again, we have our DCA 6 guide, which provides also another alternative prescriptive requirement. And with that, we will wrap up and take any questions. Thank you.
All right, Ed, thank you so much for that informative presentation. And before we hop into our Q&A, just a quick note that next month's webinar will be on Thursday, July 24th at 2 p.m. Eastern. So keep an eye out for more information on that, which will be coming soon. Okay, we have just a few minutes for questions, so let's get right to it. Ed, one of the questions that came in, someone wanted to know, should lateral loads from occupant movement be addressed in the IRC?
Yeah, and that comes up every time we do one of these deck presentations. You know, I talked earlier on about some of that lateral movement coming from wind and seismic, but really the side sway from people walking on there is what really generates the majority of it. It hasn't been in the code. It hadn't been addressed before, basically just because nobody can really come up with sort of what's the answer. How much load would we be putting on that right now? So that one does come up a lot. And what I can tell you right now is basically right now the ASC 7 dead and live load subcommittee is actually working on trying to come up with an answer for that. So once they're able to kind of come up with an answer, they can put that into the next edition of ASC 7, and then that will then eventually, hopefully, work its way into the I codes. So hopefully soon it should be coming along. Somebody did ask if there's any research and stuff on that. Washington State University actually published a lot of really good research on that if somebody wants to look some of that up.
Thank you. And I think we have time for just one more question. Someone would like to know, is the DCA 6 new and updated beyond the 2018 IRC?
Not just someone, Annie. There were many people that, as I'm sure you saw with the questions coming in. But yeah. So a lot of people, we get asked that a lot as well. So the DCA 6 right now, it's based off there's a 2015 edition, there's a 2018 edition, and then it hasn't really been updated since then. So the DCA 6 still is a viable standalone option that you can use as an alternative means of materials approval. So you know, it's still out there. You can still use it. It's certainly still, the engineering holds up. It's still very valid. We are planning on working on updating it to make it a little bit more of a standalone document. There are some really good things in there that aren't covered in the IRC, like stair stringers and some things like that. So it definitely still has its place. It's still definitely a good document that's out there. It hasn't been updated to the 21 or the 24 edition of the I codes yet, but yeah, some other updates should be coming on with those soon.
Great. Thank you for answering the question that was on everyone's mind. And that is all the time that we have for today. So thank you again, Ed, for sharing your knowledge with us. And thank you to our audience for attending today's webinar with the American Wood Council. And please remember, you will receive an email within 24 hours with a link to your certificate for this webinar. So please keep an eye out. And of course, we hope you join us on Thursday, July 24th at 2 p.m. Eastern for next month's webinar. Information and registration will be coming soon. Thank you so much for joining us and have a wonderful day.